Hi guys, in this short video, I'm just going to explain to you the process for doing the moles and molarity lab. So what I need you to do is open up your lab manual to this page that says moles and molarity. And in short, for this lab, the only 3 pages that you have to do at all are the first page. There's some blanks for you to fill in here. We'll talk about that in a second. I need you to do the second page. You're going to have to do all of these problems, and the third page, which looks like this. So those are the only 3 pages that you need to do for this lab. This page, you can leave blank. Don't scribble it out, just leave it blank, okay? I might have you fill in some stuff in here when you come in for the conductivity lab, but just leave this blank for now. And the same with these 2 pages, just leave them blank. Okay, so that's the first thing. Second thing is, really this lab is, you can cross out and molarity. This whole lab is going to be about moles. I will cover molarity in the next chapter, chapter 4. And so chapter 3 doesn't deal with molarity yet, so go ahead and cross off and molarity. It's just moles. So now let me kind of walk you through what you're going to do. You can read this front part here. One thing I want to correct, or at least change, see how it says 6.02? Go ahead and add the second 2. As you know, in one of my previous videos when we talked about Avogadro's number, we are using the form in my course with 2 2's, okay, 6.022 times 10 to the 23rd. All right, but I've already covered that topic in lecture video, so I'm not going to re-teach that. All right, so first thing you need to do for this lab is the pre-lab assignment. And essentially, it's asking you to calculate the molar mass for these, I guess, 9 different chemical species. And remember to include units. So let me go ahead and just do, I'll do the first 2 of them with you, okay? So NH3. That, of course, is ammonia. You have that memorized. To get something's molar mass, now this is a whole molecule. Whoops, that's a molecule, so it contains 1 nitrogen atom and 3 hydrogen atoms. And so you're just going to have to add up the mass of 1 nitrogen atom and 3 hydrogen atoms. And we've already done that in other places. But what you're going to get when you put that all into your calculator is 17.034. And the unit for molar mass is grams per mole. Okay, the unit for molar mass is grams per mole. Since you're writing it on a line, go ahead and write it like that. That's fine. As long as you remember, when you use it in math calculations, which I'm just going to show you in just a little bit, it's much preferable to write it like that. Okay, because that's really how, at least I do my molar mass calculations. I use molar mass as a conversion factor. So that is a more useful way of writing it. But since you're writing on a line, you can write it like that. The next one is sulfuric acid. Sulfuric acid is on your list of must memorize acids. H2SO4. So we're going to go in and calculate how much 2 hydrogens plus a sulfur plus 4 oxygen weighs. And like I said, I've already kind of showed you how to enter these in your calculator, but just let's do it one more time. 2 hydrogens, so I'm going to enclose that in parentheses. 2 times 1.008, close the parentheses, plus a single sulfur. Sulfur is 32.07, plus another parentheses, 4 times 16. And that is 98.086 grams per mole is the molar mass. Now, let me remind you, I think I've told you this before, but I never want you to round your molar masses. So don't give me rounded numbers. Just give me straight what your calculator gets you, and only use the periodic table from your textbook or the one that's on Blackboard. I want us all to get the same numbers. Lastly, let me just mention another little pitfall that some people end up having with the iodine. I2, which is the last one on the list. Iodine, as we talked about in a lecture video is a diatomic element, which means it does exist as a 2-atom molecule when it's in its elemental form. When you're just talking about iodine, if you have a bottle labeled iodine, those are I2 molecules. However, on a periodic table, the number that you see here literally is the atomic mass, or molar mass, but atomic mass, you can think of it as just one iodine atom. Each of these, whether it's diatomic element or not, represents the mass of one of them. So you, for iodine, are going to have to take the 126.9 and times it by 2, and you'll get 253.8 grams per mole. And so go ahead and finish the rest of those. You can pause the video if you'd like, but you're just going to calculate the rest of that. That's just you practicing calculating molar masses. I highly recommend that you do it all in your calculator. Don't, you know, some people over plan their approach, and they'll, you know, write how much the hydrogens weigh, and write how much the sulfur weighs, and write how much the oxygens weigh, and then write it all out and get up the total. Better to not train yourself to be so dependent on a ton of writing. Try to get yourself to learn how to just plug it in the calculator. Now, you can always check these online. If you Google a compound, you'll figure it out, usually on Wikipedia or many different places. There is the molar mass written there. Sometimes it will be called the molecular weight or the molecular mass or something like that, but it's the same number. If you're calling it molar mass, the correct unit is grams per mole. All right, so that's how you're going to do the first page. The second page is, and you don't, you know, you can, this is what we were going to do if we did this in person, but we're not doing it in person. You're basically going to be doing 12, in this case, you're doing 12 mole to gram conversions. So let me show you, I'll do the first 2 with you, and then you can finish the rest off by yourself. All right, on this page, I do need you, in order to get credit, when you show this to me, and you can show this to me the next time when you come in for your conductivity lab. When you do this, I need to see your work. You cannot just write numbers on the page. I will not give you credit for just answers, okay? In chemistry, I have to see your work. I have to see what you're doing and if there's mistakes or whatever, because part of what I'm checking is, are you learning the process? So what I'm going to write on the board is what I would want you to write on a piece of notebook paper. Better for you to do all of this work on a separate piece of paper and staple it in, because I don't see a lot of place for writing here. It's pretty crowded. So this is what I would want you to write on a separate piece of paper. So number 1, we have 1 mole, and how I would write this is like this. 1.00 moles. What the person who typed this is saying, they're saying that it's 1 mole, and then they're trying to indicate to you, hey, I want you to use the 3 sig figs, 1.00. But I would just turn this into 1.00 moles, so the unit follows the number of potassium chloride. So your first goal is for you to figure out what potassium chloride is. And I mean, I guess I'll just write it out here. If you just went straight to the formula, that'd be fine. But to figure out potassium chloride, once again, you have to think, is this an ionic compound or a molecular compound? Hopefully you know it's ionic because you have a metal and a non-metal, which means you have ions. Ionic compounds have ions. Potassium is the K+ ion based on the column that it's in. Chlorine is the Cl- ion. And so since they both are equal in magnitude, +1 and -1, the formula would be KCl. So that's what I would write on your paper. I don't need you to write all the work, at least write the formulas though. And we are trying to turn this from moles into grams. And I think I showed you this before in one of the lecture videos, but whether you're going from moles to grams or grams to mole, your ticket is to use the molar mass from the periodic table as a conversion factor. So we need the molar mass of KCl. Go ahead and get that from your periodic table. 74.55. Now, how are you going to use the molar mass? Well, in this case, now, once again, it's 74.55 grams per mole. That's what molar mass is. It's the number grams in a mole. It's really the mass of a mole. So do we want to use this right side up or upside down? Remember, that's always an option. And the answer is this one is definitely right side up. Because the whole point here is that you are needing to present the conversion factor in a way that cancels the unit that you have. So you need moles on the bottom in order to convert it to the unit that you want. So now you're really just doing this times that. Now we're timesing it by 1. Obviously the number is not going to change. The issue here is, this is what your calculator would give you, grams. The issue is sig figs. You need to present your answer in the correct number of sig figs. Now this is a multiplication problem, so you have to count the number of sig figs that went into each of the pieces that you're multiplying. He has 3 sig figs. He has 4. So of the 2, this one is the one with the fewer, which means he dictates how many are in your answer. Your answer can only have 3 sig figs. So technically, the correct answer, the 100% correct answer, is 74.6 grams. All right, so that's how you would do that. Number 2 says 2 moles. Now this time it should be 2.000 moles of bromine molecules. Now, bromine needs to have a little ding, 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 ding that goes off in your head saying that that is one of the diatomic molecules or diatomic elements. See how it's just bromine? It's not like calcium bromide or sodium bromide. It's bromine. That's the element bromine. And you have to remember that that's Br2. And that's exactly why the person that typed this called it bromine molecules and not bromine atoms, because they are existing as molecules. So we need to turn this into grams to figure out the answer. We're trying to figure out the mass. So I need the molar mass of bromine. So back to my periodic table. Whoops, 79.5 times 2. 159 grams per mole. And make sure I did that right. Nope, 159.8, my bad. Yeah, 159.8, so we're timesing that by 2. So I'm getting 319.6. And in terms of sig figs, I always just think you only care about sig figs at the very end when you're about to circle your answer. So now's the time to care. So this one has 4 sig figs, so does that one. So my answer will have 4. And that is the answer. In terms of the rest of these, I think you're good to go. Oh, I know what I wanted to say. If you back up and read the bolded words, it says you need to be able to convert moles to grams, which is what we're doing here. And gram, oh, I see. Yeah, moles to grams. See how the person wrote multiply by the atomic or molecular weight? That's code. It's the same thing as molar mass. Remember, it's the same number. See, but the way I do it, okay, this is not incorrect. It's not incorrect. It is exactly what we did. We are multiplying by the molar mass. But the way that I teach it is just think of the molar mass as a conversion factor. You don't have to think about, do I have to remember to multiply it? You'll know you need to multiply it as soon as you see the way that you have to present it to get moles to cancel. So I don't even, in my mind, I don't even think of it like that. I just think of it as use the molar. I just think of use the molar mass. And then as I'm writing it, I know what I have to do with it to get the moles to cancel and turn it into grams. All right. So that is that page. Really, to conquer this lab, you really have to get good at 3 things. Number 1 is you have to get good at figuring out the formulas. So a few of them are given, like ethanol is given because that one, it would be difficult for you to know at this point. But all the rest of these, you should be able to figure out with what you've been taught already. I will say, don't rely on Google to figure them out. You must conquer that knowledge because I'm going to, on tests find ways of asking you questions that you can't Google. So you need to get good at figuring out the formulas from the names. Now, once you figure them out, sure, go ahead and put it in to the internet and see if you can confirm it. But don't rely on that. You'll be quite cheating yourself of a good learning opportunity that you need, okay? So trust me, I know what you need. You need to know how to do this by yourself. The second page. The second page is similar but opposite. In this page, you are given the grams, and you're needing to turn it into the moles. Okay, so for instance, number 1 says 46.95 grams of, I'll just go ahead and write it out for now, and then we'll talk about copper 2 sulfate. So you're trying to do now a gram to mole conversion. You have the grams, and the answer is asking you for moles. So first thing you need, well, you're going to need the molar mass, but the whole point is the molar mass, you need to know the formula. A name is not, you're not going to be able to get a molar mass from a name. You need the formula that goes with it. So let's just do this together. We've already taught how to do this in the previous video, chapter 3 material. Copper 2, okay, that Roman numeral is there because copper is a transition metal. And the Roman numeral is telling you the charge on the transition metal. Okay, just think mentally, that's what that's telling you. And sulfate you have memorized, SO4 2 minus. So you've got copper 2 plus ions and SO4 2 minus ions. They have equal size charges, so therefore they will, when they come together, you only need one of each to get a neutral formula unit, a neutral compound. So the formula would just be CuSO4. All right, and we need the molar mass of CuSO4. So we're going to go ahead to our periodic table and add up a copper, a sulfur, and 4 oxygens. And I am getting 100, I'm just going to write it here, 159.62 grams per mole. Remember, that's molar mass is grams per mole. I'm going to just check that one more time and make sure that's right. 63.55 plus sulfur, 32.07 plus 4 oxygens is 64. Actually, you know what I just realized? The periodic table that I used, so something funny happened with sulfur in the last several years. They changed it. It must have actually gotten some more data. They changed its atomic mass when you round it. They must have changed it ever so slightly, but I'm using a periodic table from our book, actually, but it's from a few years ago, 32.07. I just peeked, because I kind of knew this was true for sulfur. See how they changed it? It's 32.06 in your textbook. So let me be perfect and use the current value of sulfur. Let me use 32.06. So $159.61. Now, that's the molar mass of this compound. Now, do you see what I'm saying? Do you want to use this right side up, or do we want to flip it upside down? And hopefully you see that we need the gram unit on the bottom, because grams is what we're trying to get rid of. And so really this is telling us that we have to divide by the molar mass, and that's exactly why this says divide by the molar mass. But I don't just teach it as rote memorization, because I want you to connect it to how units work. At the end of the day, it's much more helpful for you to just, that canceling process is what will prevent you from making mistakes when you're rushed or trying to do even harder things, because usually this is not the hardest. This is just step 1 of what we're trying to get to. you know, we will be adding other layers of complexity onto the course. So I'm getting 0.29415, but with the 4 sig figs here, I can only present 4 sig figs. So this will bump up to 2, and the answer will be moles, or the unit will be moles. That is number 1. And lastly, number 2. The number of moles in 15.63 milligrams, okay, so this is good because this allows us to do another thing here, of sodium peroxide. So let me just kind of off to the side walk you through sodium peroxide. First thing is that you have to be so familiar with peroxide that you immediately recognize it not as an element but as a polyatomic ion. So you've done your work and you've memorized peroxide because that was on your list. And peroxide is the O2 2- ion. Okay, that's peroxide. Sodium, of course, is the metal. Okay, and he must be in the ionic form because he's with an anion, so he must be the cation. And in his group, you'll remember he's O is the Na+. Now, if he is a 1+ charge, and he is a 2- charge, this is not a situation where you only need one of each. That will not get you neutral. But if you have 2 of them for every one of them, and don't get hung up on the 2, okay? This is a, you know, it's just a polyatomic ion, okay? It's a chemical species. Yes, it has 2 oxygen atoms in it, but each one of them presents just a 2- charge. So if I have one of these guys, and 2 of these guys, I will have a neutral charge, okay? That'll give me 2 positive charges and 2 negative charges. So how do I present that formula? I always write the cation first, not just me, everybody does. Na2, because remember the subscripts are there to tell you how many you have. And then you just have 1 peroxide, so that comes in as O2, because that's peroxide is O2. Remember, you don't write the charges when you're writing the neutral compound. Everybody knows that they're charged, but you don't continue to write it. All right, so that is our compound. 15.63 milligrams. Now, if you have a metric prefix, pretty much in all of chemistry, the very first thing you should do is get rid of it, because I'm trying to think of, there's maybe a couple examples where in the situation I can think of, it's, you know, you end up leaving it in there, but almost never. So let me show you why, especially you need to get rid of it here. If you want to use the molar mass is grams per mole. So you can't cancel out milligrams with grams. So we need to kind of prepare for the molar mass. So let's get rid of the milligrams. In every 1 gram, there are 1,000 milligrams. That will end up getting rid of our milligram unit. And now we're in grams. Now we're ready for the molar mass to be used. So we just need to come in and figure out our molar mass. Sodium, 22.99. There's 2 of them. And we're going to add 32 for the 2 oxygens. I'm getting 77.98 grams per mole. And now I have this set up perfectly unit-wise. You see that even though I've been doing this for a long time, I always cancel my units out. That's not something that you should it's not a sign of weakness. It's a sign of strength. Cancel your units out. Trust me, that's really, really important. The best students will always do that when they're doing their work. Okay, now time for our calculator. 15.63. Now, anything along the top you multiplied, but if it's on the bottom, you have to divide it. So we're dividing by 1,000. And I'm pressing enter after I hit this step, and now I'm dividing again by 77.98. And I'm getting a really small number, so I'm going to put this in scientific notation. Now you can either do it in your head if you're good at that. And how many sig figs? This one has 4. This is an exact number, so he doesn't matter, and he has 4. So my answer should have 4. So 2.004. I find the first number that's not a 0, that's a 2, and I start writing until I get my 4 sig figs, and then I stop, and then it's ready for the times 10 to the. And I'm moving backwards to restore the real number, because I'm pretending that it's here. It's not actually there. This is the answer. So I think about it as how many, I'm pretending that it's here, how many spaces do I have to move to get to where it really is? And it's 4 spaces to the left, so that's a -4. And then the unit is moles, and that is the answer. Remember, on your calculator, if you are feeling doubtful about your scientific notation, go ahead and just press second DRG, move over to psi, press enter, and that will do it for you. Okay, just only report your 4 sig figs. The only thing is once you peek at it, go back to second DRG and put it back in flow. You want to live in flow, trust me. Don't live in psi. You'll end up causing yourself headaches. So go ahead and finish all 12 from both pages, and that is the end of this lab. Just staple your work into this lab manual, and then you are done with this lab. So pretty straightforward. It's not really a lab, it's more of a learning activity, I guess you could call it. Getting really good at writing formulas and gram to mole and mole to gram conversions. That's all. Good luck.